Hi, my name is Jamil, and today in this section we'll be looking at quadratic functions and their graphs. Our objectives will be to learn how to complete the square, to look at graphs of quadratic functions, to learn the vertex formula, to find extreme values, and to look at some applications in modeling. Let's start by defining the quadratic equation, or the quadratic function I should say. Quadratic function. A function defined by p of x equals ax squared plus bx plus c, where a is not equal to 0, is called a quadratic function. A quadratic function will result in a graph that gives us a parabola. Now, all quadratic functions have the same basic shape, this parabola shape. It's just that they're sometimes transformed or translated on the axis and sometimes stretched or shrunk. Let's take a look at how to complete the square, which will be a useful technique in finding these graphs. Completing the square. To transform the equation p of x equals ax squared plus bx plus c into the form p of x equals a times quantity x minus h squared plus k, first, divide each side of the equation by a, so the coefficient of the x squared is 1. Second step, add negative c over a to each side. Third step, add to each side the square of half the coefficient of x. That is, b divided by 2a quantity squared. Step 4 is to factor the right side as the square of a binomial and combine terms on the left. Step 5, isolate the term involving p of x on the left. And step 6, multiply each side by a. Let's try an example that involves completing the square. Here we're asked, complete the square to write the equation in the form p of x equals a times quantity x minus h squared plus k, where we're given that p of x is equal to 4x squared minus 22x minus 12. So, following the steps we just reviewed, the first thing we need to do is divide both sides of this equation by 4. So that would give us p of x over 4 equals, and now here's the key step, making sure this coefficient becomes a 1. 4 divided by 4 gives us that 1, so we get x squared minus, then 22 over 4 can be written as 11 over 2, so we have 11 over 2x, minus 12 over 4, which can be rewritten as 3. Now, the next step is to add the 3 to both sides, so we have p of x over 4 plus the 3 that we add to this side equals x squared minus 11 over 2 times x. Now, in the next step, what we need to do is take the coefficient of the x, divide that by 2, and square it. So here our b value, or our coefficient of x, is given by negative 11 over 2. So what we're going to do is we're going to rewrite this. So we're going to have x squared minus 11 over 2 times x. And now, taking the 11 over 2 and dividing that by 2, we get 11 over 4. And then squaring 11 over 4, we get 121 over 16. So we'll add 121 over 16. Now keep in mind, this value here is found by taking our 11 over 2 and squaring it. So since we did we added 121 over 16 to the right side, we have to do the same to the left. So that gives us our p of x over 4 plus 3 plus 121 over 16. So now, continuing with this, the next step is to factor the right side into a perfect square binomial. So what that will give us is x minus 11 over 4 quantity squared. And the other side becomes p of x over 4 plus, well, 121 over 16 plus 3 is the same as 121 over 16 plus 48 over 16. So 48 plus 121 is 169 over 16. Now all that remains is to solve this equation for p of x again. So the next thing we'll do is we'll subtract 169 over 16 from both sides, and that will give us x minus 11 over 4 quantity squared minus the 169 over 16. And now finally we'll multiply both sides of the equation by 4 to get p of x alone. So when we do that, we get 4 times quantity x minus 11 over 4 quantity squared minus, and then 169 over 16 times 4 leaves us with 169 over 4. So From this form, what we can do now is take a look and find the vertex of our parabola. It's now written in the standard form of the parabola, or in other words, a times quantity x minus h squared minus k. So we can read the vertex directly because the x value of the vertex is given by the value of h, which is 11 over 4. And then the y value is given by the value of the k, which is negative 169 over 4. Why don't you take a look at this next example and try to complete the square and find the vertex of this one. Here you're asked, complete the square to write the equation in the form p of x equals a times quantity x minus h squared plus k, and then give the vertex of this parabola. You're given the function p of x equals 2x squared minus 2x minus 24. Give this a try and check back with me when you've completed it. Okay, let's see how you did with that one. Here you were given the equation p of x equals 2x squared minus 2x minus 24, and you were asked to complete the square. So we'll start by dividing both sides of this equation by the value of 2, because that's the coefficient of the x squared. This leaves us with p of x over 2 equals, and then 2x squared divided by 2 is x squared, minus, and then 2x divided by 2 is x, minus, and then 24 divided by 2 is 12. So from here, the next step was to add the 12 to both sides. So we have p of x over 2 plus 12 equals x squared minus x. And now you have to find the value to add to both sides to make this a perfect square. Remember, to find that, you take the coefficient of the x, divide it by 2, and square it. So here the coefficient of the x is negative 1. Negative 1 divided by 2 is negative 1/2. And when we square that, we get a positive 1/4. So what we want to do here is on both sides, we want to add a positive 1/4. So adding it to the right side, and then going back, and then adding it to the left side. Now by doing that, we've created a situation where we can factor the right side into a perfect square. So let's go ahead and factor that side of the equation. X squared minus x plus 1/4 can be factored into x minus 1/2 quantity squared. And the other side of the equation becomes p of x over 2. 12 plus 1/4 becomes 49 over 4. So now solving this for p of x, the next step is to subtract 49 over 4 from both sides. So that gives us x minus 1/2 quantity squared minus 49 over 4. And now as the final step, getting p of x alone, we'll multiply both sides of the equation by 2. And we'll end up with p of x equals 2 times the quantity x minus 1/2 squared minus, and now 49 over 4 times 2 gives us 49 over 2. So now, here's the answer that we were asked for, the equation of p of x written in this form. And now to answer where's the vertex, we need to go ahead and look at this and read the vertex from the appropriate places. Remember, the vertex is given by hk, where it's x minus h. So our vertex here has an x-coordinate of positive 1/2, and then the k value is given at the end, and it's found to be negative 49/2. So we know the vertex of this parabola is 1/2 negative 49/2, and don't forget about the coefficient out in front as well. This coefficient tells us the stretch factor for the parabola. Since we have a 2 as the coefficient, we know that our parabola is being stretched by a factor of 2. Now that you've seen how to use the complete the square method to write the other form of the equation of a parabola, we should go over the rules for graphing parabolas. Let's take a look at those. The graph of p of x equals a times quantity of x minus h quantity squared plus k. The graph of p of x equals a times quantity x minus h squared plus k, where a is not equal to 0. First of all, this is a parabola with vertex located at hk, and the vertical line x equals h is an axis of symmetry. Next, this will open upwards if a is greater than 0, and it will open downward if a is less than 0. And then, this will be broader than the graph of y equals x squared if 0 is less than the absolute value of a is less than 1, and narrower than the graph of y equals x squared if the absolute value of a is greater than 1. Now the key to graphing a parabola is being able to find the vertex. What we have next is the formula to help you find the vertex. So let's look at that. The vertex formula. The vertex of the graph p of x equals ax squared plus bx plus c, where a is not equal to 0, is given by the point negative b over 2a, comma, p of negative b over 2a. So let's take a look at an example where we can use this formula. Here we're asked to use the vertex formula to find the coordinates of the vertex, and then we're asked to graph this function by hand. We're given the function p of x equals x squared minus 10x plus 21. So in order to find the vertex, we'll make use of the vertex formula, which tells us that x is equal to negative b over 2a. So using this, we know that we have a negative, and then our b value is the coefficient of the x, so that's negative 10. Then over 2 times a, or the coefficient of the x squared, and that coefficient is 1. So we're given negative 10, and that gives us a positive 10, over 2 times 1, which is 2. So we know that the x-coordinate is 5. Now, in order to find the y-coordinate, what we need to do is substitute this value 5 back into our original function. In other words, we'll be looking for p of 5. And in this case, that's equal to 5 squared minus 10 times 5 plus 21. 5 squared is 25. 5 times 10 is 50. So we have 25 minus 50 plus 21. This gives us 25 minus 50 is negative 25, and a negative 25 plus 21 is negative 4. So we know that our vertex is located at 5, negative 4. Another useful thing to notice is the y-intercept of this graph. Remember, we can find the y-intercept by substituting in the value 0 for x. Finding the y-intercept, we find that p of 0 equals 0 squared minus 10 times 0 plus 21, which is equal to 21. So that gives us the point on the graph 0, 21 as well. Now, in order to make a sketch of a parabola, this is really all we need. Finding the vertex and the y-intercept, we can find a third point because we know that parabolas possess symmetry. So let's take a look at the graph of this. Remember, on this graph, we had found the vertex to be the point 5, negative 4. So marking that point 5, negative 4, we have a vertex located here. We also found that the y-intercept was at the value 0, 21. So that takes us to this point here. So it's like going over 5 this way and then up to the y value 21. So doing the same thing, going the other direction, though, that would take us to the x value 10, and the mirror image will still have a y value of 21. So we have this point, and now we can sketch the parabola by connecting these points. And there's a rough sketch of our parabola, with the vertex shown at the point 5, negative 4. Now, the vertex of any parabola will always be either the maximum or the minimum value. These values are referred to sometimes as extreme values or extrema. Let's take a look at what these extreme values are. Extreme values. For the quadratic function defined by p of x equals ax squared plus bx plus c, first, if a is greater than 0, the vertex hk is called the minimum point of the graph, and the minimum value of the function is given by p of h, which equals k. Secondly, if a is less than 0, the vertex hk is called the maximum point on the graph, and the maximum value of the function is given by p of h equals k. Let's take a look at an example that asks us to find some extreme values. Here we're asked to give the coordinates of the extreme point of the graph of each function and the corresponding maximum or minimum value for each function. The first function we're given is p of x equals 2x squared plus 4x minus 16. So in order to do this, what we need to do is find the vertex. In the first equation, we're given that p of x is equal to 2x squared plus 4x minus 16. Since the a value here is 2, that's an a value that's greater than 0. We know that this extreme value will be a minimum according to the rules we just saw. So now to find the vertex, we'll make use of the vertex formula, which tells us that x is equal to negative b over 2a. So substituting the appropriate values, negative b, well in this case the value of b is 4, because that's the coefficient of x, over 2 times the value of a, and the coefficient of the x squared, or the a value in this problem, is 2. So that gives us negative 4 over 2 times 2, which is 4, which gives us negative 1. So we know that the x-coordinate of this point is negative 1. To find the y-coordinate, we substitute in the negative 1, and we get p of negative 1 equals 2 times negative 1 squared plus 4 times negative 1 minus 16. Negative 1 squared is positive 1, so that becomes a 2. 4 times negative 1 becomes a negative 4, so we have 2 plus negative 4 minus 16. When we do 2 minus 4 minus 16, we end up with negative 18. So our vertex in this case is given by negative 1, negative 18. Since we know this parabola opens upward, this is a minimum value. Let's look at another example and do the same thing. Again, we're asked to find the extreme value of this particular parabola. We're given that p of x equals negative x squared minus 6x minus 8. In order to do this, we first have to find the vertex. So using the vertex formula again, x equals negative b over 2a. And substituting in the appropriate values, b in this case is negative 6. 2 times the a value is negative 1. So we have negative 6, which is positive 6. And then 2 times the a value negative 1 gives us a negative 2. And 6 divided by negative 2 is negative 3. So the x-coordinate is negative 3. Substituting in the negative 3 into the equation to find the y value, we get negative 3 squared minus 6 times negative 3 minus 8. Now, being careful to keep track of our negatives here, negative 3 squared is a positive 9, but with a negative in front, that makes it a negative 9. Then we have a negative 6 times a negative 3, which gives us a positive 18. And then we have a negative 8 at the end. So negative 9 plus 18 minus 8 gives us a value of positive 1. So here we find that the vertex lies on the point negative 3, positive 1. And now to determine whether or not it's a max or min value, we look at the value of a. Since this value is negative, the parabola opens downward, and that makes this point a maximum value. Now that we've seen how to find the maximum and minimum values of a parabola, we can use parabolas for many different applications. One such application is finding the height of a propelled object. Let's take a look at this. The height of a propelled object. If air resistance is neglected, the height s, given in feet, of an object propelled directly upward from an initial height of s sub 0 feet with initial velocity v sub 0 feet per second is given by the function s of t equals negative 16t squared plus v sub 0 t plus s sub 0, where t is the number of seconds after the object is propelled. Let's try an example that makes use of this. Here we're told that a ball is thrown directly upward from an initial height of 100 feet with an initial velocity of 80 feet per second. Give the function that describes the height of the ball in terms of time t. Well, using the equation we just saw, where s of t equals negative 16t squared plus v sub 0 t plus s sub 0, and filling in our information from this particular problem, we know that s of t equals negative 16t squared plus the initial velocity, which is 80, and it's positive 80 because it's thrown upward, so it's plus 80t, plus the initial position, which we're told the initial height is 100 feet. So our function is s of t equals negative 16t squared plus 80t plus 100. Now let's look at the next question. Graph the function so that the y-intercept, the positive x-intercept, and the vertex are visible. So what I've done here is I've taken the graphing calculator and I've input the equation into the graphing calculator y1 variable, and now we'll go ahead and take a look at the graph. So here we can see the parabola graph for us. You can see the positive x-intercept as well as the y-intercept and the vertex all in this viewing window. In the next question we're asked, after how many seconds does the projectile reach its maximum height, and what is its maximum height? Now, in order to do this, we can use the graphing calculator to find the maximum for us. We can start by going to the maximum built-in function, and then using that, inputting the left and the right bound. The graphing calculator will come up with a maximum value of 2.4999 repeating. When this happens, what we do is we like to round the value because the appropriate answer would be x equals 2.5. So the maximum height occurs after 2.5 seconds, And then the y value gives us the maximum height, so y equals 200 or 200 feet would be the maximum height that this particular object reaches. Question D asks us, for what interval of time is the height of the ball greater than 160 feet? Now, in order to do that, what we need to do is go to the graphing calculator and graph the function y equals 160. Now, by graphing this, what will happen is we'll see our two functions graph simultaneously, and we can visually see where the parabola lies above the horizontal line. So all we need to do is find those points of intersection. So finding those points of intersection using the built-in function on the calculator. The first point of intersection is given to us as x equals 0.91886. So we'll round that to 0.92. Now, even though the calculator is using the variable x, we should really be using time as our variable, so it will be t equals 0.92, we'll say. And now we'll go back to the calculator and find the other intersection point. So using the calculator for that, moving the cursor over to the appropriate intersection point, we find that our x value here is 4.08. So again, that's a time value, so I write t equals 4.08. So what that means, when we're asked for what interval of time is the height of the ball greater than 160 feet, we know that it's between the 2 points we found. So anytime t is greater than 0.92, we move above 160 feet, and it stays above 160 until the time reaches 4.08. The last question that we're asked is, after how many seconds will the ball fall to the ground? In order to do this, what we'll need to do is find the x-intercept. I've already changed the window size so it's more appropriate, and we're going to use the 0 function in order to find the positive x-intercept in this case. So what we need to do is find the 0 of this particular parabola, and using the calculator, it returns the answer that t is equal to approximately 6.04. So our answer is that the time will be 6.04 seconds when the ball reaches the ground. In this section, we've taken a look at parabolas in depth. You've seen how to complete the square in order to make the parabola easier to graph, as well as found formulas to find the vertex and the maximum and minimum points of the parabola. You should work on the examples in your textbook, and I'll see you next time.